Okay, everyone, good morning and happy Friday. Today we're going to be looking at lesson 47. So if you'll please make sure that you have your packets ready and have your books as well, that would be helpful. Today's title is Rate Unit Conversions, and we're going to do a little bit more on fractional exponents. We started that on Thursday, but let's look at the rate unit conversions to start with. Now I'm going to go get an empty sheet of paper because I want to do an example for you to just watch, and then we're going to go ahead and build a couple into our notes. So what's important to know about rate unit conversions? Well, rate unit conversions contains 2 units of measurements. Just for an example, that's what IE means, by the way. For example, you might have miles per hour. See how that's 2 units of measurements? Or you might have feet per second. How fast can that person run? Feet, how many feet per second does somebody run? Okay, or how many miles per hour does the car drive? So it's 2 units of measurements. So let's look at an example of what that is like to start with. Okay, so let's say you're asked to use unit multipliers to convert 42, I'm going to write this down, inches per second to miles per hour. I'm going to put a line here to kind of separate this. There we go. Okay, so we're going to use unit multipliers to convert 42 inches per second to miles per hour. There's 2 steps that I want to kind of make a note of over here. The first step would be, and this is actually written in the top of your notes there, you're going to write the given units in fractional form. So in other words, this 42 inches per second, we're going to write it this way, 42 inches per second or per 1 second. Okay, now we want to go from that, we want to go from inches per second to miles per hour. That's going to be our goal here. Okay, so we've written it in fractional form. Step 2, we always convert the distance first. And then we convert the time. Okay, so let's look at this. So I'm going to just rewrite this down below. So I have 42 inches per second, per 1 second. I'm going to write second as SEC because if I just put an S, it might end up looking like a 5, and I want to be careful about that. Okay, so the first thing that we want to convert according to step 2 is the distance. So our unit multiplier has to have the same measurement in it. So if it's length or it's distance, then both the top and the bottom need to be distance. So let's think about what our first unit multiplier needs to be. Well, I always look up here at this inch right here. And I know that if that's inch, then down here needs to be inch. Because remember, we want to do this cancellation. Okay, so we're trying to get to feet. We're trying to get to miles. But in my mind, I have to think, well, when I'm thinking about miles, what's a standard measurement that I know kind of by memory that I can use as a conversion number? Well, I know 5,280 feet is 1 mile. And since we're trying to get to miles, we want to go from inches to feet to miles. Okay, so here we go. So we'll say 1 foot is 12 inches, and I can cancel out my inches. My next unit multiplier has to be feet on the bottom, right? Because we're going to do that canceling thing again. So 5,280 feet is 1 mile, and we can cancel out the feet. The next unit multiplier now is, and since we're at miles, and that's where we needed to land, remember? Miles is where we're trying to go. So I'm going to stop there on my distance, and I'm going to pick up time. So now we have to do the time. So since we're trying to get from seconds right? We're trying to go from seconds to hours. I'm going to make my first conversion has to have, I'm going to start with 60 seconds because I'm at the seconds first. And I want to be able to cancel that. Actually, I'm going to stay in the orange pencil for a bit here. I want to get rid of those circles. Okay, the reason I know I want to start with seconds is because look over here. I want to be able to cancel those out. So 60 seconds and 1 minute. There's the first unit multiplier. The next one is going to be, minutes will be up here now. So trying to get to hours, so let's go ahead and use our 60 minutes can be equal to 1 hour, and there's that. And then I'm going to cross out those minutes. So let's see if I landed where I needed to. So I was trying to get from inches to miles, and I did have the miles as the last distance one that's left, and I wanted to get from seconds to hours, and it looks like hours is what's left. Everything else is crossed out. So we've done a good job there. Now we just want to circle everything that we need to multiply. I don't usually circle my ones. I don't need to because I don't have to write those. But I do need to write this. I also have those two right there. All right, so let's go ahead. Remember, Saxon does not make you work them out, but I'm going to anyway, just for the sake of seeing what it really turns out to be. So I would have 42 times 60 squared, because I have two 60s up there, over 12 times 5,280. And if you want to put that in your calculator, let's see what you come up with. This should give you 151.2 over 63,360. And if you divide that in your calculator, you're going to get, actually I want to see if it's estimated. Hang on. 151.2 divided by 63,360 equals. Okay, so we're going to have to round it because you're going to get 2.38636 and so on. So we're going to round that to 2.39. So it really is approximately miles per hour. Or it can be written as 239 miles per hour. Both of those are correct, but that's the answers right there. Okay, so that's how you convert something that's got two different measurements, distance and time. So let's try another one. I'm going to show you one more, and then we're going to build into our notes, I think. Let me see. Maybe this next one's going to go in our notes. Let me look. Actually, yes. So let's go ahead. I'm going to go back to our note sheet. Right here, example 1. So let's look at this. So we're going to use unit multipliers to convert 480 miles per hour to feet per second. Okay, so we always write what we're starting with first. And remember, step 1 up here says write the given units in fractional form. So let's take this 480 miles per hour and write it in fractional form. So you're going to have 480 miles per hour. So we'll put it over 1 hour. Let's build in a unit multiplier, figure out what we need. We know the bottom. Now remember, we start with distance, and then we're going to do time. So distance, I'm going to be dealing with the miles part of this beginning measurement. Miles is going to go down here because we want to be able to cancel those out. All right, so 1 mile. Now think about it. We're trying to get to feet. So this is actually going to work out pretty nicely. 5,280 feet, and I can cross out miles. Boom, boom, right there. Okay, so we've already landed. This is really working out nicely because we've already got feet, so we can stop because that's what we need. We can stop on our distance measurement. Now let's pick up time. Let's make a unit conversion, or excuse me, a unit multiplier for time. Alrighty, so I know that hours has to be up top. How do I know that? Because look here, hour and hour. I want to be able to cancel those. So I know that I want to put hour on the top. And I'm trying to get to seconds. But I'm going to go ahead, I'm going to go ahead and use minutes first, because they always want you to go one step at a time. And then I'm going to go and cancel out my hours. And now I'm going to go with my minutes here. So 1 minute and 60 seconds. You can cross out those minutes. And I always like to go back and circle what I need. Let's get a different color here. We use orange. All right, so we have 480, we have 5,280, and we have feet. We have 60, 60, and seconds. So now we just simply write this out. We would have 480 times 5,280 over 60 squared feet per second. Now, if I wanted to put this in my calculator, it's going to be a nice big one here. You're going to get 2,534,400. I encourage you to try this in your calculator over 3,600. And when you do the math on that, you're going to get 704 feet per second. And that would be the answer to that one. Okay, not too bad. Let's look at the next one. We're going to convert 15 inches per second to yards per hour. Now remember, in our notes, we're supposed to convert distance first and then time. But before we do that, we need to take the given units, what's given as the 15 inches per second, and write that in fractional form. So we're going to put 15 inches per 1 second. Okay, now we're trying to get to yards per hour. Okay, so let's do our distance first because that's what step 2 says, convert distance, and then we'll convert time. So if we're going to think about distance, now I'm looking at the inches here. So I know that I'm going to put inches on the bottom, and I'm trying to get to yards, so we have to start with our feet. We can cross out our inches here. The next one, we need feet down here. And since we're trying to get to yards, this will be a good time to be able to do that. So 3 feet is 1 yard, and I can cross out my feet. And look, I'm going to go ahead and I'm going to circle yards because that's where we needed to land. Now let's deal with the time. The time, okay, I've got seconds over here. So that means my next unit multiplier will have seconds up top because I want to be able to cancel that. So 60 seconds, and we're going to put a minute on the bottom. And the reason is because now I'm trying to increase to find out the hour. Okay, how many yards per hour. So now I have to grow this from seconds to minutes to hours. Okay, so we can cross out seconds over here. You guys see where I did that? Don't miss what I just did. Seconds, I'll do it in green so you can see. We cross out seconds. Now, the last unit multiplier, we can put minutes up here, and we can put hours on the bottom. 60 minutes equals 1 hour. We can cross out our minutes here. And we have successfully gotten to hours. Okay, so you can see we have yards. I've circled them in green, yards per hour, and that's exactly what we wanted to come to. So let's circle what we have. We have 15, 60, 60, 12, and 3. So let's write that as an answer. You're going to have 15 times 60 squared over 12 times 3. If you do the math on all of that, by the way, you're going to have 54,000, and you can please try that in your calculators. I encourage that. And you're going to get 1,500 yards, that's what we're trying to get to, per hour. Okay? And that's how you do unit conversions for rate conversions that have 2 different measurements in it. Okay, now the second part of this lesson is just a little bit of an expansion on what we were doing on Thursday. Remember, we were looking at these square roots or cubed roots or even larger roots. In this case, our first example has a larger root, but I'm going to go back up to a blank sheet of paper, or rather down to a blank sheet of paper, because I'm going to do one to show you how to do this. Now, this is where it gets tricky, and actually, in the Saxon book, they even say this could be considered a trick problem. So I'm going to show you an example, and then we're going to build one in your notes. But let's say we have the cubed root of 27 times the cube root of 3. Now, it's a trick problem because I really need to have the same bases, because remember, what I'm going to do with this is I need to pull this out into like a fractional exponent. Okay, and that's what we're trying to do here. We want to take this whole mess of numbers and make it a fractional exponent. But the first thing that I need to do is think about making the same bases. So let's pull this out. Let's look at 27. 27 can be written as 3 to the third power, right? 3 times 3 times 3 is 27. So let's rewrite that. And also, you want to kind of think about this. And in your notes, you're going to see off to the right there. Here's some examples. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 27 is 3 cubed. Those are just some common numbers that you want to know how to rewrite those with an exponent, because you're going to need to identify those in some of these problems. All right, so all I've changed so far is I took that 27 and I re-expressed it as 3 to the third power. That's the only thing I've done so far. Oops, 27. Okay, that was step 2. Now, I want to take this and make fractional exponents out of it. Remember how we did that? Sometimes we have to do brackets. Sometimes we can be using just parentheses. But right now, I'm going to use a bracket because on the inside, I'm going to take this square root of 3, and that's going to go inside its own set of parentheses. So watch what I do, just to kind of remember on some of this. So I'm going to take out the 3 to the third power and put it right inside here. I'm going to multiply it with the square root of 3, but I'm going to write the square root of 3 as a fractional exponent. So what is that? 3 to the 1/2 power. And this whole thing is actually is the square root of or excuse me, the cubed root. So we want to make this 1/3 on the outside. Okay, so now I have this written as fractional exponents. Now let's do the work. Now remember, since this is on the outside of our parentheses, since 1/3 is on the outside, you need to multiply that with every exponent that's inside those parentheses and brackets. So let's do that. So 3 to the third power, when you multiply that with 1/3, you're going to get 3 to the 3/3 power, right? Or 3 to the first power, or just 3. But we're going to leave it as 3 to the third power because we might need to use that in just a moment. And then when we multiply the 1/2 over here with 1/3, you're going to get 3 to the 1/6 power. Now we need to add these two. Now we add our exponents, because remember, this is like having x to the third times x to the second. Remember, that's just x times x times x times x times x, which is x to the 5th, right? So how did I get that? I can add these together to get x to the 5th. The only time we multiply those exponents is when it's outside the parentheses, like it is here, okay? All right, let me erase all that. Go back to blue. All right, so now I need to add 3. I need to add these exponents, 3 to the third plus 1 to the 6th. Well, I need common denominators here, so I'm just going to change this to 6 over 6 times 3 to the 1/6 power, and I'm going to end up with 3. Remember, our bases stay the same. It's like when you add together, or you put x and x together, you keep it the x as x. All right, so we have 3 to the 7/6 power, and that's the answer to that problem. So these are exactly like the ones we were doing yesterday. The only glitch is that we have to there might be a number in here that we need to change it to the same base that's inside there with it. Because see, when we pulled it out in fractional form, we want the same bases. Because in the end, down here, we can combine those. Okay? Now let's look in your notes. And we're going to build one in. And then we'll do the practice problems and we'll call it a day. All right, example 3. We have the 6th root of 4 times the square root of 2. So notice I need to have the same base as what's in here. So this 4 is going to have to become something different. Look here. We're going to re-express it as 2 to the 2nd power. So I'm just going to rewrite this for just a minute so we can see it as 2 to the 2nd power times the square root of 2. Okay, now we can pull this out and write it in fractional form. I'm going to go this way so I don't run out of room. Okay, so I'm going to make my big brackets here, and I'm going to pull the 2 squared out. That's the first thing. 2 squared. And I'm going to go ahead and put that one in parentheses because we're going to multiply that with this next one. Now I have to take this and rewrite it as a fractional exponent. So remember how to do that? That would be 2 to the 1/2 power. Now the whole thing is the 6th root of, okay? So that becomes 1/6 out here, the whole thing. Now we have something we can work with. So I need to now take 1/6 and multiply it with this exponent, which is going to give me 2 to the 2/6 power multiplied with 2 to the 1/12 power. Now we add these, but notice I don't have the same denominator, so I'm going to just change the denominators real quickly here on this one here. Whoops. That becomes 2, and the exponent is 4 over 12 times 2 to the 1/12. Now I can add my exponents. I'm going to get 2 to the 5 over 12 is how that works out. And that's how you do those problems. Exactly like yesterday, the only new thing that's being added is taking and making sure we have the same bases in there. So you might have to re-express the whole number that's under there, okay? So let's look at, I think we did A and B in class yesterday. Didn't we? Oh, no. I'm getting tired. It's late at night. Okay. No, we didn't do A and B yesterday because this is a new lesson today, silly Mrs. Quigley. All right, so let's look at A. And that would be on page 208. So if you would like to pause the video, try it yourself, come back and check your answer with mine and see how you did. If you did fine, you can just move on to the next one. If you didn't, you'll at least can go through the steps with me. I'll have that here for you to see. So I'm going to go ahead and write the problem. The cubed root of 64 times the square root of 4. Alrighty, here we go. So I'm going to re-express 64 as 8 squared. And notice something here. Actually, I'm going to write this underneath because I want you to be able to see it. So I'm going to come underneath here. So I'm going to keep the cubed root. I'm going to keep everything under here for just a minute. So I'm going to have 8 squared. But notice that this square root of 4 can actually become 2 underneath there. So this one might work out pretty cool. All right, so let's see what we have. So underneath here, I would have, I'm going to go ahead, actually I'll go this way now. All right, so I'm going to put a big bracket here because I want to pull the things out from underneath the radical sign. Okay, and I'm actually going to separate those 8s. 8 times 8, put them in parentheses here, times 2. And all of that is going to be raised to the 1/3 power. because, right, we have a 3 out here. So that becomes this 1/3. All right, let's keep going. Now I'm going to multiply this with each exponent. Well, each number inside there, the exponent is actually 1. So you're going to have 8 to the 1/3 times 8 to the 1/3 times 2 to the 1/3. Okay, now I'm looking here at something. I should have looked this over before I did this. 2, 2, and 2 to the... Oh, okay. All right. Now this is gonna be very interesting. So watch this. Notice I have 8 to the 1/3 power. Well, what is that? Remember, that was just this, the cube root of 8, right? So what is the cube root of 8? The cube root of 8 is actually 2. So I'm going to actually write that right down here. This is 2. This is 2. And I have 2 to the 1/3. Okay? I wanted you to see that. So I'm going to come over here and write that again because I want to be able to put it where you can see it. So 2, where I can keep going. All right, now I need to add my exponents together here. So each one of these first 2's has an exponent of 1. So those need to become 2 with an exponent of 3/3, 2 with an exponent of 3/3, and 2, we have the 1/3 there, right? Let's go underneath here. I have a base of 2, and I'm going to add those exponents. 3 plus 3 is 6, and 1 is 7/3. That's the answer. Now, if some of you came out with an answer that's 4 with an exponent of 7/6, that is also correct. Okay, so I want to make sure that you knew that. Okay, letter B. Here's another one. We have a problem that looks like this. 9 times square root of 3. Okay, so already I identify that I need to take this 9 and make it with a base of 3. So we're going to rewrite this like so. 3 squared times the square root of 3. And then I'm going to pull them out, like I've been doing, into brackets and parentheses. So I'm going to pull the 3 out, 3 squared, and the square root of 3 there is 3 with an exponent of 1/2. But the whole thing, because remember over here, you got to keep thinking about that guy. The whole thing would be raised to the power of 1/6. Okay, now we do our multiplication of exponents. So I'm going to come over here now. I'm going to end up with 3 and 2 6, which is the same as 1/3, but I'm going to leave it as 2 6. I'm not going to reduce it here yet. That's inside there, and then 3 and 1/12. And that's the reason I didn't reduce it, because actually I need to have common denominators of 12. So let's keep going. 3, and I'm going to make this 12, so it's 4/12. And 3 and 1/12. So now I can add those exponents, and I'm going to end up with the base of 3. I add those exponents, and they're 5/12. And that would be the answer for letter B. Okay, C, this is the first part that we learned. So C says that we are going to use unit multipliers to convert 85 miles per second to miles per hour. All right, so we always write down what we're starting with. 85 miles, and we write it as a fraction per 1 hour. Okay, remember, we convert distance first and then time. So let's do distance. Well, distance is miles, so I need to put miles down here. And I'm trying to get to, where am I going, did it say? We're at 50 miles per second. We want to go to miles per hour. Oops, I think I wrote something down wrong. I'm sorry. Per second, right? Yes, I'm sorry. Second. Okay, so we know that hang on one second. Okay, because we're already at miles. Okay, I'm sorry. Oh my goodness, it's getting so late. All right, let's try this again. So we're going from 85 miles per second to miles per hour. So there's no distance conversion that's needed because we already have miles in the top. Okay, so we don't have to worry about distance. Miles is already there. In fact, I'm going to circle it so you can see, because remember, I always circle it when I'm there. All right. So now we just have to worry about converting the time. We know we need seconds up here, so I can cancel those out. So I'm going to use a minute to 60 seconds. And then I can go to I can put minutes up here. And I'm trying to go to hours, remember? So we went hours on the bottom here, so 60 minutes to 1 hour, and we can cross those out. Now let's go circle what we have. 85 with two 60s. We have miles and we have hours. So we successfully did that. So we have 85 times 60 squared miles per hour. If you work that out in your calculator, you're going to end up with 306,000 miles per hour as your answer. All right? All right, letter D. I'm going to use black now, or dark blue. Okay, letter D. We're going from 207 miles per hour to feet per second. So I'm going to write that up here so I don't forget. 207 miles per hour to feet per second. Okay, so that's the conversion that we want to make here. So we always start with our given rate, which is 207 miles per hour. In this case, both our distance and our time need to be converted. So we're going to start with distance first. Okay, so we look at the miles. So our first unit multiplier is going to have miles in it. So if we're going to feet, this is going to be good because we know that 1 mile is 5,280 feet. We can cancel out the miles. And actually, we have already gotten feet because that's what we're trying to get to here. So now we're in a position we can go ahead and make a unit multiplier with time. All right, so I go back over to the time that was given, which was hours. So I know that hours has to go up here. So I can cancel those, right? So 1 hour is 60 minutes because we need to get all the way down to seconds. So we have to make one more unit multiplier. So cross out hours, times, and we're going to put minutes up here and seconds down here. 1 minute is 60 seconds. Let's cross out those minutes and let's go circle what all that we needed. So we have 207, 5,280 feet, 60 seconds. See, that's what we were trying to get to, is feet per second. So here's feet, here's the second. So the answer is 207 times 5,280 over 60 squared feet per second. And actually, I did do the math on that. You could try it too. If you do, you should come up with 303.6 feet per second. Okay, but this is acceptable right here as well. Okay, so that is the lesson in a nutshell. I hope to see some of you on the Zoom call today with some questions to help get through the lesson. So please feel free to do that. You can pop in and pop out as you get your questions answered. Please know that this lesson will be due next Tuesday, along with all the other lessons that were supposed to have been turned in on Thursday, but since so many people weren't there, I extended it till next Tuesday. So please make sure that all of your lessons are ready to be turned in at the beginning of class. I'll probably go over some answers with you first, but have them done and ready on Tuesday because they all need to be turned in. On Thursday, you'll be having a test, and we'll talk about that a little bit more on Tuesday. Okay, guys, have a wonderful weekend, and I hope to see some of you on the Zoom call.